Hello Math 7 students, this is Utah Middle School Math Project 4.2g about proportional and non-proportional relationships, and I have also included some of Open Up Resources Unit 2 Lesson 7. We've combined both of these resources into one because they're all talking about proportional and non-proportional relationships. Let's get started. Focusing first on Utah Middle School Math Project 4.2g, proportional and non-proportional relationships, we have this situation here. It says your dad has researched renting jet skis for your family vacation, and he found the following cost plans for two different places. Rental plan A, you pay $30 initial one-time rental fee plus $45 per hour. Rental plan B is $50 per hour with no initial one-time rental fee. This is kind of some big words here. Will you please discuss what in the world does this mean? This $30 initial one-time rental fee and no initial one-time rental fee. Quickly discuss with your groups. What does that even mean? Okay, and now come back to me and tell me, what do you think that actually means? All that discussion and only one hand. That's better. We'll go with Luke.
It's kind of like, so the initial one-time rental fee is kind of just like, all right, I give you $30 up front, and then you ride it for a couple of hours, and then they total up the hours, and then they multiply your hourly fee by how many hours.
Yeah, that's a really good explanation, and I love how you really made it makes sense for the real world. You said $30 initial one-time rental fee. That's saying, here you go, here's $30 up front, right? I think that's great. That's exactly the kind of situation that would be. Why would companies do that? Why would they say you have to pay us $30 right out of the gate? Any ideas? Oren, what are your thoughts there? Yeah, if you at least run off with the jet skis, you at least have $30. Sometimes it would be like a reservation fee, where like you call them and say, hey, I'm going to be down this weekend. Will you hold these jet skis for me? And they'll say, yeah, but you have to put a $30 deposit down, right? That way, if you don't show up and they were saving those jet skis for you so they didn't give them to anyone else, they at least still got their $30. So yeah, and this is a strategy that a lot of companies will do, especially when they're like, yeah, it's a very real thing. So $30 one-time initial rental fee, and plan B is no initial fee. We don't have to pay anything there. So now let's compare the other parts. And I mentioned to students in class that I'm going to be color coding. So here it says plus a $45 per hour, and rental plan B says $50 per hour. So if I'm just comparing hours to hours, like this is $45 per hour, this is $50 per hour, which one seems cheaper? Joshua? Yeah, it seems cheaper, right? However, when we now take into consideration, yes, we're only paying $45 per hour, but look at what we have to pay, this extra $30, then it changes things a little bit. So we've gotten this table started. Let's continue on with it. Remember, I'm color coding, so rental plan A, I'm going to continue to do in blue, and rental plan B, I'm going to continue to do in red. All right, so I'm going to focus on rental plan B for right now, just because it's nice and easy. We have $50 per hour. We're not paying any extra fee. So 1 hour, that's 50 times 1 for a total of $50. For 2 hours, that's going to be 50 times 2 for a total of $100. You get the drift, right? 3 hours, 50 times 3 for a total of $150. 4 hours, that's 50 times 4, $50 an hour, 4 hours for a grand total of $200. $50 an hour for 5 hours is $250. We're going to keep these other ones blank for just a minute. We'll decide what we want to do with those. Let's see what this looks like when now I have this one-time rental fee. Okay, so here it's already set up for us. 1 hour, we have to pay $30 one time. Why are we paying that $30 one time? Carter? Exactly. It's our deposit. We have to pay that one time. And in addition to that, we now have to pay, it says plus 45 times 1, right? Why are we paying that? Because that's $45 for that 1 hour. What's our grand total then? $75. Okay, what are we going to put here? Check in with your groups. This is where a lot of students can make mistakes if they don't have an understanding of what this means. So I want you to give it a try. Check in with your groups. We'll come back together in about 15 seconds. Ready, set, go. Okay, come back to me. What should we put here? How much is this going to cost? Joshua. You got it. 30 times 1 plus 45 times 2. Now hold on a second. 1 was in parentheses here, and that was 1. 1 was in parentheses here because it was 1 hour. Now 2 is in parentheses because it's 2 hours, but this still is a 1. Remind me why that's happening that way, Carter. Exactly. 1 time rental fee. So what is that cost going to be? $30 times that 1 time we have to pay it, plus $45 times the 2 hours. So that's 90 plus 30. I got 120. What'd you guys get? Same thing? Fantastic. All right, let's move on. Let's continue to follow this pattern. 3 hours. Well, we're still paying that $30 one-time fee, but now it's $45 an hour for the 3 hours that we're going to be there. This one is not quite as easy to math in our heads. I got 165. What'd you guys get? Same? Thank you, Tanner. Let's make sure we're using our calculators. Don't rely on me or Tanner to do the math for you. Make sure that you guys are doing it as well and checking our work. 4 hours. Once again, we're still paying that $30 one-time fee. But now when I'm out on those jet skis for 4 hours, that's 45 times 4. This gives me a total cost of, help me out here. Do you have it, Devin? Do you have it, Alexis? We have a few hands now. Go ahead, Olive. Good. That's what I got in my head. All right. We get the drill here now, right? $30 times that 1 time that we have to pay that $30 plus 45 times our 5 hours. And good. We have more hands that time. You guys are getting quicker with those fingers in the calculator. What'd you get here, Oren? 255. I like it. Let's not even worry about these blank spots right now. Let's just kind of compare what's happening in the table. I'm going to go through and I'm going to highlight which one is more, or which one is cheaper. Okay, so if it's 1 hour, which one is cheaper? Rental plan B, right? 1 hour 75 or 1 hour 50. 2 hours 120 or 2 hours 100. 3 hours 165, 3 hours 150. That one's still cheaper. 4 hours 210, 4 hours 200. Still cheaper. 5 hours 255, 5 hours 250. Still cheaper. Is that always going to be the case? Do you see how the numbers are getting a little bit closer together every time? All right, so let's test this out. Let's go to the 6 hours. Let's see what's happening there at 6 hours. 6 hours, we've got our $30 one-time rental fee plus $45 an hour for 6 hours, so 45 times 6. I got 300 there. You guys get the same? Okay. And here, $50 an hour times 6 hours, that's going to be 300. So 6 hours for 300 or 6 hours for 300. Now, I'm going to skip around a little bit. For these remaining spots here, I want to go 7. And I want to go 0. And I know it's not in order, but it's okay. We can do that with tables. We can put in any numbers that we want. So 7, That's going to be our $30 one-time fee, plus that $45 an hour for 7 hours this time. Here I'm getting, let's see, 300. Oh, you have it for me, Joshua? Great, thank you. Gonna just finish up this table here. What if I have the 0? Will you quickly discuss with your group? What is that going to be? It's going to be 0, right? Talk with your groups. What's that going to look like over here for the 0? Carter? Exactly, it's going to be $30 because even if I don't show up to rent those jet skis, I still put down that $30 deposit. So it still is a $30 one-time fee. And it's $45 an hour, I just didn't show up, so it's 0 hours. So 45 times 0 is 0, but I still paid that $30 deposit, that initial one-time fee. Over here with Plan B, that's $50 an hour times our 7 hours, so we have $350. 0, that's $50 an hour times 0 hours, so that's 0. Great. Let's continue on though. Which one is cheaper? So 6 hours, it's 300, 6 hours, 300. I can't highlight anything, they're the same there. 7 hours is 345, and 7 hours is 350. That means rental plan A is going to be cheaper here, right? Noticing some interesting things there. And now I want you to challenge yourself. I'm going to pause the recording because I want you to try and write your own equation for each of these. Continue to follow the same pattern that we followed throughout the whole table and you'll be successful. Pause the video and give it a try and we'll come back together to test out our equations. Ready, set, go. Let's start with this one. We know this one. We've had problems like this all over the place. What is the equation here, Davin? Yeah, exactly. We just take what's over here, we multiply it by 50, and so that equation is going to be y equals 50x. Exactly right. What is it going to look like over here with rental plan A? We have not seen equations like this, and to be honest, writing an equation like this is actually an 8th grade level problem. Are you ready for it? Give it a try, Cambria. You got it. 30 times 1 plus 45 times x is exactly what we would do. Now, I'm going to simplify things a little bit because we know what 30 times 1 is, right? We've kept that 30 times 1 to remind us it's a one-time fee. But what is 30 times 1? It's just 30. So when I write it over here in this column, I'm just going to simplify it. And instead of 30 times 1, I'm just going to say 30. Sorry, I'm going to start with the y equals, though. Y equals 30 plus that 45x. Got it. Interesting things that are worth noting here. One of these is proportional and one of them is not. Which one is the proportional one? Luke. How do you know that it's proportional? You're right, so tell me why.
Because every time to get from x to y, you multiply by 50.
Exactly right. We have a constant of proportionality here. 1 changes to 50 because we've multiplied by 50, right? We can see it here. How did this 5 change to 250? The constant of proportionality, we multiplied by 50. That's exactly right. Do we see anything as nice over here? No, there's that extra step, right? Yes, that 2 is multiplied by 45, but that's not what we write here. We also then add an extra 30. So we don't have a constant of proportionality here. 1 times 75 is 75. So it would appear that the constant proportionality is 75 until you test it out down here. And then it would be 2 times 60 is 120, right? So this one, we already know this one's proportional. I'm going to go ahead and label it. This one is not proportional. We don't see that constant of proportionality. Let's further confirm. We can kind of suspect what we think that these graphs are going to look like based on our previous lessons, but let's create graphs for each of these situations. Once again, I am going to color code, and because I have done this problem in years past, I'm going to give you some hints on a good scale that we should use. Along the x-axis, I'm going to be measuring hours. How do I know I'm measuring hours? Here's the x, in the hours column, right? That first column is always going to be our X. So here's our X-axis where we are measuring hours, and I'm going to scale. That means I'm going to count by ones. So each one of these grid lines here is 1 hour. That means the y-axis is going to be, again, take a look, here's our total cost, that final column, that's our y. So the y-axis is our cost. And the best way, with all the many times that I've done this problem, the best way to scale it, anyone have any guesses? Looking at the numbers that we're trying to graph, what would you guess is a good scale to use? Oren, what do you think? I actually go a little bit smaller, I go 25s. Yeah, good guess though. And you could still do it with 50s, but if you want yours to look like mine, keep it 25s because that's how I'm going to graph it. But again, I'm lazy. I don't want to do every single one. 25, 50, 75, 100. 125, 150, 175, 200. 225, 250, 275, 300. 325, 350, 375, 400, 425, 450, 475, and $500. And now we're going to go ahead and plot those points. I'm going to be color coding as I do this. So my rental plan A, I do have the point 0, 0. No, 0, 30. It's going to be about here-ish. 1 hour will be $120. And this is one where you don't have to watch me do all of these points. You can just do them on your own and then check at the end to make sure that they're all good. I'm going to continue to plot these points on the recording for those who need help with plotting those points. 2 hours. Oh, I'm making mistakes here. 1 hour is 75. 2 hours is the 120. 3 hours is 165. So here's 150, here's 175, so it's going to be in the middle of those. 4 hours is 210, so here's 200, it's going to be a little bit higher than that. 5 hours is 255, so 200, 225, 250, going to be just a little bit higher. 6 hours is 300. And then I did also have 7 hours. 7 hours was 345, so just a little bit less than that, 350. Before I move on to try and graph the other one, I am going to use my straight line tool because I'm going to assume that if I don't have it out for the entire time, then they are not going to make me pay that whole extra fee. So maybe if I'm only out for half an hour, they'll only make me pay half of that. So I am going to connect it with a line, assuming that that line makes sense. You can see that I didn't plot all of my points perfectly, so I'm just going to make those adjustments so that they all land on that line. Maybe it's not cooperating very nicely. But I am going to color that line. Okay, let's graph Plan B. Plan B, we have over 0, up 0, because if I'm not renting it, I don't have to pay for Plan B. 1 hour is 50. 2 hours is 100. 3 hours, 250. 4 hours, 200. They're getting closer and closer. 5 hours was 250. It almost looks like they crossed there, but not quite. 6 hours, they do officially cross because they're both 300. And I did 7 hours as well, was that 350. That one's now officially higher. And as I go and connect these with a nice straight line, those ones were easier to find, so those do land very nicely, and I'm going to color code that line as well. All right, and now I'm going to go back to that full screen view. Carter, you had a question. Good. Why is there a line for the blue one when it isn't proportional? Because we already know it's not proportional, right? Not proportional, so why is it still a straight line? And the answer, can I have all eyes on the screen? Let's take a look at the table. Even though it's not proportional, we see a consistent pattern. We see a constant rate of change. Take a look at this. How is that 75 changing to 120? This time we can't do it with multiplication. What's the difference? How much am I adding to 75 to get it to be 120? Carter? $45. Why did I add $45? Because we rented it for 1 extra hour. Let's take a look at this change. All eyes on the screen again. Help me out here. Big brains. How does that 120 change to 165? What am I doing? Adding $45. Why am I adding $45? Because I rented it for an extra hour. Last time I'm going to ask this question. Let's skip down. How does that 255 change to a 300? We add $45. Why am I adding $45? Because I added an extra hour of time. Compare that over here. How does that 50 change to 100? Don't think multiplication this time because we're going down the table. How does that 50 change to 100? We add 50. Why did we add 50? Because we added an extra hour of rental time. So, even though, and I'm so glad that you asked, even though we don't have a constant of proportionality, we don't have a nice way of going across the table, it's a straight line because we still have this consistent pattern as we go down the table. And that's what we call the constant rate of change. So, even though it's a straight line, why is it not proportional? Look at some other characteristics of this blue line. Why is this blue line not proportional? It's a nice straight line, so what's going on? Joshua? Yeah, it doesn't go through the origin. It crosses the y-axis right here at 30 for that $30 one-time initial rental fee. So it can still be a straight line, it's just not going to go through the origin if it's not proportional. Great observation. We're done with this problem. What questions do you have? Okay, so we have seen in the past in our last couple lessons, we did see what it would be like if a line doesn't go through the origin, seeing that it's not proportional. We can relate that to what we're seeing in a table, and now we're relating it even further to a context. Now, here's another situation, another side-by-side. Allie and Barb are both filling swimming pools at a constant rate of 2 gallons. Listen to that. Constant rate of 2 gallons. Did you hear what I said on that last problem? Did they both have a constant rate? Were we constantly adding $45? Or constantly adding $50 here? Okay, so we can still have a constant rate, and they're adding the 2 gallons every half of a minute. Allie's pool started with 6 gallons of water in it, while Barb's pool was empty. Let's start with that information in our table. Again, we're adding 2 gallons every half of a minute. Is this counting by half minutes? No, let's make a change then. I don't want to hurt my brain when I'm building that table, so let's just take care of that now. If it's 2 gallons every half minute, that means every 1 minute. What's that going to be? How does that 1/2 change to a 1? I'm doubling it, right? So what am I going to do with this 2? Double it, just using equivalent ratios. So that's going to be 4 gallons every 1 minute. That's going to help as I'm filling out that table. What am I going to start with? Allie's pool started with 6 gallons. So here's Allie. How much is in her pool in the beginning? 6 gallons. Barb's pool was empty. How much is in Barb's pool in the beginning? 0. Yep. Maybe I need to switch those. I'm going to switch those so that I have some consistency in our notes. That's not what I wanted. I'm sorry. This one is the blue one with 6, and this one is the red one with 0. That's what I wanted to do. Okay, let's complete those tables. If it's that constant rate, then 1 minute later, you can see I've added a minute of time. So when I add a minute of time, that means I've added 4 gallons. 6 plus 4 is 10. Continue on. Another minute has passed. So we have an extra 4 gallons, that's 14. Another minute has passed, an extra 4 gallons, 18. Another minute has passed, an extra 4 gallons, that's 22. Another minute, another 4 gallons, 26. Uh-oh, I didn't just add 1 minute, did I? In this last spot on the table. How many minutes did I add? 3. So how many gallons am I going to be adding here? Yeah, good job. If I'm adding 3 minutes, that means I'm adding 4 gallons, 4 more gallons, 4 more gallons, each of those 3 minutes, for a total of 12 gallons. So 26 plus 12 is equal to 38. Let's go on back over to Barb's pool. She starts with 0, 1 minute later, and she adds 4 gallons. So 0 plus 4 is 4. Another minute, 4 more gallons. 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 Uh-oh, same thing. 3 more minutes, that means 12 more gallons. 20 plus those 12 extra gallons is equal to 32. All right, let's get those graphed. Challenge here, I want you to write equations for both of them as well, right? Like I said on this page, if you can write an equation here for this non-proportional, that's an 8th grade level problem. You're in 7th grade. If you can do that, that's fantastic. If you can't, that's okay, but challenge yourself and see if you can figure out what that equation is going to be for both Barb and Allie, and then talk. Are those relationships proportional? As you go through that and say yes or no, they're proportional, describe it. So what that's going to look like down here. You're going to say it's proportional and I can see it in the table by this. It's proportional and I can see it in the graph by looking at this. It's proportional and I can see it in the equation by looking at this. Or if it's not proportional, those same things. So you're going to talk about what it looks like in the table, what it looks like in the graph, and what it looks like in the equation. I'm going to pause the recording so that students can work with their groups to answer these questions. We'll come back together and do it together. With your groups, get it graphed. Write equations and determine which ones are proportional, and how are you going to look at each representation to determine that. Pause the recording, give it a try. Ready, set, go. All right, let's fill out these graphs. Barb is 0 and 0. Over 1 hour, up 4 gallons. Over 2 hours and up 8 gallons. 3 hours and 12 gallons. And you can see as I'm filling this out, all of this is turning out to be nice, perfectly, or all these points are landing in a nice straight line. And then we're going to jump it to 8 and 32. So even when I jumped ahead and skipped, notice that it maintained that pattern. There's a big gap, but it maintained that pattern. Again, the discussion of should I connect these points with a line or not? Let's draw the line and see if those points make sense. If in only half a minute, will half of the amount of water be in there? Yeah, of course. In only a quarter of a minute, will a quarter of that amount of water be in there? Of course, it doesn't all just splurt out of the hose when we're filling our pool. At that 1 minute mark, it happens throughout that time. So I'm going to go ahead and color that line. And then we'll move on to Allie. Allie started with 6 gallons in her pool. So over 0 and up 6, she already has 6 gallons. She is still filling it 4 gallons every minute. So 1 minute has passed, 4 extra gallons. At 2 minutes, she has a total of 14 gallons. At 3 minutes, she has 18 gallons. 4 minutes, 22 gallons. 5 minutes, 26 gallons. And again, I'm going to skip ahead. 8 minutes, all the way up here, 38 gallons. And again, I can still see that all of these land in a nice, perfectly straight line, but it's different from the red line because something else is happening there. Let me try that again. Select it and then blue. All right. With that in mind, we're ready to answer the next ones. Let's write some equations. Here is Allie's pool. Allie started with her 6 gallons, and even though she started with 6 gallons, she still added 4 every minute. This is that 8th grade level equation that if you can't quite figure out, that's okay. But here's how it looks. We started with those 6 gallons. So even though I started with 6 gallons, I'm still adding 4 gallons every minute. X represents those minutes. So this is going to be y equals 6 plus 4x. How is that different here with Barb? Well, with Barb, it's that constant of proportionality. How is a 1 changing to be a 4? How is a 2 changing to be an 8? Or a 3 changing to be a 12? We can see that all the way through we're multiplying by 4. Again, we can talk about how we can write those equations later, but since that's an 8th grade level problem, we're going to skip that for now. Y equals 4 times x. So we now have our 2 equations. Barb, y equals 4x. Allie, y equals the 6 gallons that she started with, plus 4 every minute. y equals 6 plus 4x. Are these relationships proportional? Lots of ways that you can see it. And again, I can see it here in the table for Barb. Very easy to see that constant proportionality. Here, I'm not seeing it. I can see that a 1 would change to a 10 by multiplying by 10. But now a 2 multiplied by 7 is how it would be 14. And a 3 multiplied by 6. So even though I can find relationships to go across the table, I can see that these are not the same number. So we don't have a constant of proportionality if it's constantly changing, right? So it's easy to see in the table that Barb has a proportional relationship because she has a constant of proportionality. I'm going to write that down. The constant of proportionality, which I can see in the table, is 4. And again, when I look at Allie's, we saw that there was not a constant of proportionality. We could find a relationship to multiply, but it changed every time. It was not constant. So in Allie's, there was no constant proportionality. The number we multiply by to go across the table, it changed. Let's take a look at the graph. Are they proportional? Again, taking a look at these two graphs, we can see that they are both straight lines. Yes, I'm going to fix something here. I should have done this before. Let's label these lines. Even though we've color-coded, let's label them as well. Barb is red and Allie is the blue. And we can see that Allie's, even though it's a straight line, it does not go through the origin. And since it does not go through the origin, that means that Allie's is not proportional, and it does mean that Barb's is a straight line going through the origin. Barb's is proportional. We already confirmed that here with our tables. Now we're seeing it in a different relationship, confirming it with our graphs. So in the graph with Barb's, we saw that it was a straight line through the origin. And with Allie's, we can see that although it was a straight line, it did not go through the origin. With the equations, this is something that we really haven't had to focus on too much, but you can see Barb's equation, y equals 4x, that looks very familiar. It looks like other equations that we have written. Allie's has something different, and I hope that you can see that the thing that's different is that. We have a 4x, we see that right here, that's fine, but the part that's making things weird is that she started with her 6 gallons. That's exactly the same reason why when we look up above, why we see that it didn't go through the origin, because it started up here on the y-axis at 6. That's what's making it not go through the origin, because we started with those 6 gallons, we added those 6 gallons right at the very beginning. So in the equations, we can see that we are only multiplying. That's the only thing that's happening. We're only multiplying. And even more than that, we're not just multiplying, we're multiplying by that constant of proportionality. We saw the constant proportionality is 4. What is the number we're multiplying by x? That's 4. So only multiplication in the equation, we're multiplying by the constant of proportionality. And we can see in Allie's, that's just not the case. The equation has addition in it, and it's that addition that's making things look a little bit crazy. That's it for this video. We will continue this lesson in another video, so stay tuned. Thanks for watching, and we'll see you next time.